All right, so our goal is really to look at how do we help our students if they're struggling with multiplying binomials. So if we think to even the interim, a lot of our students, if they missed this question, they jumped to the basics, right? They thought, okay, it's x squared, and then a lot of them saw the plus 10, but what they didn't see was that we needed to multiply our terms also, like the 5 times x and then the 2 times x. So what we're going to do is use an area model to actually give that meaning to our students so that they understand what we're doing. I'm going to actually share with you what it looks like in younger ages. So this is what they do in 4th grade. So if students are first learning how to multiply 25 times 12, then what they're actually going to do is break it apart. So they would see this as 20 plus 5 for that 25. And then they would see it as 10 plus 2 for that 12. So in this case, if we're actually going through and wanting to multiply those, then we can kind of break it piece by piece. So the 10 by 20, the 10 by 5, the 2 by 20, and the 2 by 5. And that's actually common practice that's happening in our classrooms regularly. So when we're thinking about our students that are in 4th grade right now, this is what they're seeing as their types of problems that they're first learning when they multiply 2-digit by 2-digit. And then eventually what happens is we shift. So they shift from using the base 10 blocks to then just drawing it with an area model. So they're still seeing that 25 as 20 plus 5 and that 10 plus 2. And then they're going through and multiplying each of those different pieces once it's decomposed to get to their final answer. All right, so this common practice of the area model isn't totally foreign to our students. They've seen this in elementary school. So we're going to use that to help connect and explain how we would actually multiply binomials. So I'm going to shift this out of the way. And if I was looking at this, what I tend to like to do is actually, I kind of create these lines to represent my factors that are being multiplied for that actual area. So if I'm looking at x plus 5, the first thing I need to do is define with my students what these algebra tiles mean. So this is going to represent x squared. So it's nice visual for them. They see the square. This is what's going to represent our x. Green is positive, red is negative, and this is going to be our units. So this is 1, positive. If I flip it over for red, it's negative. And this will be familiar to them for those of the in 7th grade as they're working with counters and things like that. So if I'm looking at x plus 5 and I want to actually represent that factor, I know I have 1 positive x, and then I have 5 of these units. So give me a second. So I'm going to represent that up along the top. So that's my first factor. Now I also know that I am multiplying that by the quantity x plus 2. So I can represent that with 1 green tile, and then 2 positive tiles because I have 2 positives. All right, so going back to what they're already familiar with when we're thinking through with these area models, we're going to go through and do the multiplication for each of those terms. So in this case, we're saying what is x times x? Well, I know that that is x squared, and so I'm going to represent that with this positive blue x squared tile. I'm also saying what is x times 1? Well, a positive x times a positive 1 is positive x. And I'm going to continue that for each of these pieces. So if I'm doing x times 1 5 times, then I have 5 positive x tiles. Okay. Down here, now I'm looking across. I still have to have these 2 1 units being multiplied by my x term. So 1 times x is again a positive x. 1 times x is again positive x. And then we've got 1 to go. We have the 2 here times the 5 here. So we know 2 times 5 will give me 10 positive tiles. All right, so bear with me as I build real quick. So what this did is it gave meaning to the mathematics. So we asked them to do this operation, and a lot of times traditionally, if we're honest, we teach FOIL, or we're doing these loops with all of these different ways of trying to expand. And students miss something, or they forget to distribute and they get confused. But when I use this model now, and I'm actually looking at it visually, I'm seeing the x plus 5, and I'm seeing the x plus 2, and I'm seeing that when I multiply those factors, I have 1x squared, I have 5x here, 2x here, and 10 units, just 10 ones. I'm also seeing my like terms in a visual way for our students. So really, I have a total of 7 x's. So I have 1x squared, 1 unit of that. I have 7 of my x variables, and I have 10 of my 1 units. And there's my answer. So the times when a lot of our students just see the first and the last when they're multiplying, this visual helps them see why we have the 7x also. Okay? So take a moment. Does anyone have questions about that first example that we walked through? Feel free to unmute, or I believe there is a chat feature somewhere here, if I can find where it is, and you have a question. Are there any questions out there about this first example? Maybe a thumbs up if you're good with the first one. Okay, thank you. I see a couple thumbs. All right, so I'm going to do one more with you, but I'd like you, if you have your algebra tiles, we can do it together, okay? So in this example, let's look at x plus 3 and then x subtract 2. So the quantity x plus 3 times the quantity x minus 2. So if you have algebra tiles, then you can build this. Now, I'll even share this mat if you want just to have the template. It's just a basic, I just made a line and a line. But you typically have something like this when I taught it in the classroom. I just put it in like a sheet protector. And then students could practice throughout it, and then they could use their expo marker to write on that sheet protector as they worked through their thinking. All right, so you guys want to try it for this one together? So we're looking at the x plus 3. I want you to kind of think through what would that model look like if you were to build it. And remember, we're kind of looking through these pieces. And if you have your tiles with you, awesome. Kind of ignore me and work on trying to build that first factor. Okay, so most of us should have that 1x tile and then 3 positive units. Now the x subtract 2, we're going to want to have that 1 positive x. And then the difference for our students this time is that instead of using the positive tile, they're going to use the negative to represent those minus 2. All right, and then we go at it again. So in this visual, we have x times x. So again, there's our nice x squared. Again, we have a positive x times a positive 1. So we're going to have a positive x. And we're going to see that that happens 3 times. All right, everyone doing okay with that part? We good? Following me? All right, down here, the only difference now is that we're multiplying it by a negative. So we have a negative 1 unit being multiplied by a positive x. So in this case, I'm going to have a negative x for my term. So a negative times a positive is a negative. And then I'm going to repeat that same thing here, again, to have a second negative x term. And again, with my units, I'm going through and multiplying. So I have my positive 3 up here and my negative 2. So again, a negative times a positive is a negative. So as I go through and fill in my area model, I see my negatives. All right, so at this point then we're ready to take our visual and mathematically represent it. So what do we have? We have x squared. We have 3 positive x's. We have 2 negative x's, and then we have a negative 6. So this also helps our students that are struggling with our integers. So I know you still have some out there that are struggling to see this. Well, they are familiar with our 0 pairs. So here's one 0 pair. Here's another 0 pair. So what's left? A positive x. So really, I just have x squared plus 1 positive x, and then the minus 6. And there's my answer. So I know that x plus 3 times the quantity x minus 2 is equal to x squared plus x minus 6. All right, are we feeling okay? Thumbs up. Would you be able to model this if you were working with a small group of students that still struggled with multiplying polynomials? Any questions out there for me on those first ones? Okay, I'm seeing it was clear. Any questions on, okay, and then be real with me. How do I use this with students? What would this look like in my classroom? Any questions out there for this first part? Do we need one more example of just a binomial by a binomial with the tiles, or do we feel okay about that? Because if not, I'll shift. Kind of, how do we go the next step? One more? Okay, so just a second. I'm going to go ahead and, all right, so now we're looking at this example. So we've got the quantity x minus 4 times the quantity x minus 1. And when you're doing it with your students, make sure that we kind of start off with the basic, because we're going to shift to modeling this representational for the more challenging ones. So we're just building foundation and understanding here so that when they see more complex ones, they're not having any nerves. And I'll go through this one kind of a little bit with you just because I see, and awesome, I love that there's 7 of you here from Creekland, awesome. If some of you feel like you've got it, maybe try this with like a 2x, so you can kind of switch it up to see if you could do more challenging. It works for everything. It works for binomials, it works for trinomials, whatever you want to use, you will find that it shows it perfectly. So let's try this one. Ignore me for a minute if you have those algebra tiles, and start working through x minus 4. And what I love about this is it does help as a visual for your students that are still struggling with integers. So I know it's like a tendency, we want to drop everything and save them because they're struggling with their integers. We've got to find ways to just embed it within the new learning so that we're still helping them, we're still providing that support. We don't want them feeling lost and frustrated, but at the same time, we're getting to the curriculum that we need to see. All right, so hopefully you matched me and you have x minus 4 and then x minus 1 as our 2 factors that are being multiplied. And again, I'm just gonna keep reminding you, they see this in 4th grade, they see this actually in 3rd grade. This is foundational to our students that we're seeing right now in 8th and 9th grade. It's finally moved on up to them. So if you have any students in the elementary world, you would recognize this as well. All right, so let's multiply. So we've got x times x, which gives us x squared. Now in this one, we're going to be doing a positive x times a negative unit. So if we have a positive times a negative, we know it is a negative x. And we're going to continue that for each of those because a positive times a negative is a negative. We also have a negative 1 being multiplied by a positive x. Okay, so same thing. I'm going to model that with that negative x. Now at this point, we're looking and saying, okay, so for our units, I have a negative 1 unit and a negative 4 unit. So a negative times a negative, though, is going to be a positive. So our students are going to see that it's not always going to look the same. It depends on our scenario. And again, I'm just going back to these outer units. And sometimes if you're working with groups and they're still struggling, even writing it to help them see again. I'll move that over again. Okay. All right. So what's left? We have an x squared. We have minus 4x. So 4 negative terms there. Another negative x, but there's 1. Again, this helps them see that relationship. The missing 1 here is right here. and then this time, positive 4. So at this point, if I'm going through and putting it together, how many x's do we have? 1, 2, 3, 4, 5 negatives. So it's x squared minus 5x plus 4. And awesome, I see Sweetwater has a good little viewing party too. So yay, I'm so excited to have y'all. Okay, so that's it. And now we've got this representation. Okay, so let's be honest. This is a great visual way to get started with understanding the why. Why am I doing this? Why did all of a sudden when I multiplied these two binomials, it went into 4 pieces and eventually into these 3 terms, x squared, x, and 4, or in a 1 unit. So our students aren't gonna have algebra tiles when they're taking a test, all right? So if you go back to what we looked at for that 4th grade example, we wanna help shift them from the concrete to where they can draw it as a representational, because they can answer this question using a model that is representing what they had in that hands-on tactile way first. So if I look at this example right here that we have in here, I know that I was multiplying 4 different things, right? Because it was a binomial multiplied by a binomial. So that's where I have my 4 things. 2 here and 2 here. I had an x and a minus 4. So I just wrote this first part right here, what we visually see up at the top. And I have an x minus 1. So I draw this with my students. And at this point, we're gonna do the same thing that we did with the tiles, but just using our mind. So x times x gives me x squared. X times negative 4 gave me 4 negative x tiles. Negative 1 times x gave me 1 negative x, or you could even put that 1 if you want for the coefficient. And then negative 1 times negative 1 gave me positive 4. So right here, I have the terms that we wrote out over here. So if I'm a student looking at this, I could rewrite it now left to right if that helps me visually see it, and do exactly what we did up here, because now I know in my mind that these are my like terms. So I really have x squared minus 5x plus 4. Okay, are we feeling all right about this one? Okay, this is where we want to get our students. Honestly, I'm fine if we never teach them slope, because it's only going to work for binomials. And this actually is going to work for anything that's being multiplied, any polynomials. It could be trinomials, it can be whatever you want for the model, and it's always going to work, and we're never going to miss distributing something because we understand the meaning of what's happening. All right, so I use this model for everything when I'm working with students. And I did this with, when I taught, I had EL students, I had special ed students, and I promise you, this was the way that we didn't have mistakes, because they were able to see every single piece versus the good old fashioned making lines and calling a little trick. So I'm gonna shift to ones that are more complicated, all right? So we've got this model and how we've connected it now to the area model. If we look at this, okay, it's a little trickier. If I wanted, I could build this out using the models. Like I technically could put 2 x's and then a positive 1. And then I could keep building this out, because what it would do is then it would just show me that it's 2x squared once I build the whole thing, okay? So if you have students that you need to go here, you can, and you could show even the more extreme cases. But I'm gonna shift just for time purpose to us using it with the area model. So what do I see? I still see 2 terms here, a binomial by 2 more terms here, another binomial. So I'm gonna build my visual off of that. I've got 2x, another term is plus 1. This also lets me talk about the vocabulary. We're talking about terms, we're talking about coefficients, we're talking about all of those pieces. That is one of our other AKS, where we're just talking about the components. We've got an x and we've got a minus 2. But what I don't need to do is just have a question, tell me which one's the constant. I'm using it regularly in instruction so that they're seeing the meaning behind it. Okay, so here's my binomial by my binomial, and now I'm gonna multiply. So what is x times 2x? Well, this is excellent for our students that are struggling, because if I did use a visual like this, what is x times 2x? It's 1, it's 2x squared. It's 2x squared. So they're seeing that expansion when we're looking at it. What's x times 1? Well, just 1x, right? All right. What's negative 2 times 2x? It's negative 4x. What's negative 2 times positive 1? Negative 2. All right. Again, I could take that, and now I can expand it. So I've got 2x squared plus 1x minus 4x minus 2. And we know here's our like terms. So again, if I need, I can help with that visual, because we're seeing components. But what I found was, because I started with those fundamentals and did it enough with students, I didn't need to keep bringing out the tiles. They started to have some context to this. But again, there's my 0 pair. So what's left? Just those 3 negatives. I still had algebra tiles out, though, for the student who didn't get it. And if they were telling me negative 5, or if they were telling me positive 5x for this, I made them show me. I got those tiles out and said, prove it, and had them grapple through and work with that problem so that they could do it and then go, oh yeah, that's a 0 pair, and move on, okay? And I'm gonna show one more with you, because while this isn't gonna help us for quadratics, this stuff certainly will. Our next Zoom, I'm gonna show how to reverse this to help them with factoring. But if they see this on the EOC when it comes up, or if they see this on any of our finals and so forth for our district assessments, again, I can use an area model. What's the difference here? Instead of it being a binomial times a binomial, it's now a trinomial, because I have 3 terms in this piece. So I'm just going to draw that accordingly. Now, this is personal preference. I just like to make the longer one go across the top. So I'm actually going to make my trinomial the top term, but you do whatever makes you happy, all right? So your students, they'll set it up whichever way, because it doesn't matter. Either direction, still going to get the same answer. But I'm going to put my trinomials up at the top, all right? There's my x squared, there's my minus 2x, there's my plus 1. And then I'm going to put my binomial along the side, x plus 3. Okay, everybody following me with that? I know it's a little different, but same concept. And we're going to just do it again. We're going to build the area model by multiplying. So I have an x times x squared. Well, that's now x cubed. I have x times negative 2x, negative 2x squared. And I'm just going through and multiplying each of the terms until I finish. Oops, yep, okay, so here we go. Again, now I'm gonna write it out. What do I see? I see an x cubed. I see 2 versions for the x squared. So I have a negative 2x squared, and I have a positive 3x squared. I also see 2 versions for my x's. And then I see a positive 3. So this one's a little trickier, right? Because they're gonna have to do these. And I can even whip these back out if I need to help them see it. But I've got 2 negatives, I've got 3 positives. So what we really know is we have x cubed and we have 1 positive x squared. And then again, I've got negative 6x plus x. I've got 6 negative x's and I've got 1 positive. So I've got 1 0 pair, but there's still 5 negatives there. And what's left over? The 3 units. All right. Like I promise you, when I did this, it was the least number of errors in terms of that distribution, because it had meaning to it and they could visually see it, and it was very clear where did it go. Super effective for my SPED and for my English learners, so they didn't feel overwhelmed when they looked at something that does look overwhelming from the beginning. Okay, so I just threw a lot at us. My goal is to get this in 30 minutes, so there is 4 minutes. I will do a fun little preview. Next time in our Zoom session, I'm going to show you how to go backwards. So we're going to look at fun stuff like this, and then how do I get backwards to this. So we'll talk about factoring. So that's what's coming up in quadratics. So that will be a little tip for you there. Are there any questions? Feel free, you can unmute yourself or type in the chat bar. I saw that Berkmar High is here, Jones Middle is here. So yay, I love everybody that's here. But are there questions as you looked through the different examples that you need clarified? No other questions? We're feeling good? Okay, so my goal is to make this short and sweet, but you have one coming? Okay, I'll wait for a second to see where that comes. Maybe I'll reshare the screen in case we need to model it. Let me find my chat, I just lost you. And if you're good, so I'll definitely, once we have that question coming, but I think it gives me a warning. We have 40 minutes total, which I kind of liked about Zoom. It forces us to get some learning, but also honor our time, because I know you're all so busy. And feel free, if you want to unmute, I can certainly talk it through again. Oh, is there a reason why I use the positive sign for X in the first box, but not on the outside? No, I probably for consistency should make it the same in all. No reason. A lot of it, when I was in here, it's kind of to help them see as they're setting up once we actually put it all together. But really, we probably could do it consistent for all. It's just personal preference. I guess that's how I've done it, and no one's ever pointed it out to me, to be honest. And so I just kept doing that. Great question. Any other questions out there? Feel free to use the microphone, and hopefully I answered that question correctly. But yeah, I probably could put it here to help as well, to visually see it. So with the algebra tiles, there is not a way to model the x to the third power. So typically, unfortunately, because it's flat, and so we stop at that. Typically what I'll do is we could talk to them about what x cubed is. If you think about it, it is a cube when we're going through the pieces. And hi, Dr. Birds. But if it's getting to where we need a visual, I'll just do expansion with them. So we know x squared is x times x. So if we're multiplying it one more time, it's giving us that third x, which I guess if we wanted to, this is just me talking out loud, so don't all like hold me to this. I wonder if there's a way we could kind of model it with this to show that 3D element, because that's kind of what's happening. But I've found that typically if I build it and give it context here, we are okay once we get into the model to then just use expansion to help. So then if it's say x to the fifth here, then they can see it through expansion. Or if it was like if we were doing say 2x squared times x to the fifth, we could show them that's really 2 times x, and then 5 more, so that they get 2 to the 7th. Well, I can't count. There we go. So I kind of see set it up the foundation with the algebra tiles. Then once we shift to representational and it gets too complex, I just go back to the old-fashioned way. Good question. Anything else that we have questions? Do we feel like we could take this and use it with our students that maybe didn't have so much success with this the first time? I know in the interim there was one that quite a few, if they missed it, they just did boom, 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 and forgot these friends in the middle. So this might be an opportunity to pull some students in a small group and try this. All right, any other questions? We sure? I don't want to close it, but I also want to honor your time. You're welcome. Y'all, I'm such a geek. I'm so like secretly excited that we are all together. So I'm super excited. We've got more to come, lots of learning to do. I like this idea if you all do, just of these quick snapshots, but it honors your time a little bit more versus having to drive in. And I know you're all busy. Please know, I know you're all doing so much out there. So I appreciate you. If you get going with this and you have questions, send me an email. I am one email away and always happy to help. Okay? All right, my friends, it's 5:02. Let's honor our time. Please have a great evening. Some of you heading out to Teacher of the Year. I will see you in a little bit. and have a great night, please. Okay? Thank you, thank you. I'm going to go ahead and end our session then.